dead ants lay scattered beside a rock. At first, there was nothing unusual about it. Ants die all the time for 1,000 different reasons. This was different. There were far too many of them, almost the entire colony. Tiny bodies littered the ground around the nest, and for some reason, their heads were lying separately. Among the dead, a handful of survivors were still running around. They darted aimlessly, crashed into one another, scrambled back into the nest, then came rushing out again. These ants had no idea what had happened, and they didn't know they didn't have much time left either. But who exactly had fallen victim to this unknown killer? They were little fire ants, a tiny invasive species originally native to South America, which eventually spread across the world through international trade. In Israel, they were first discovered in late 2005 in the Jordan Valley, and from there they began spreading farther. The problem is, little fire ants have an incredibly painful sting, and the pain can last for hours, sometimes even days. And these ants don't attack alone, they swarm their victim and sting again and again. For small animals, an attack like that's usually fatal. For larger ones, it can mean shock, illness, and if they're unlucky, death as well. So basically, these guys were 100% villains, and now every single one of them was dead. But before that pile of dead bodies appeared outside the nest, the colony had already started falling apart from the inside. And what happened was seriously strange. For a while, the ants still looked almost normal. They moved around, returned to the nest, came back outside. Basically, they carried on with their usual ant routine. But that was only an illusion. The first thing to stop was the normal flow of food. Worker ants usually spend all their time searching for food and carrying it back to the colony because the entire nest depends on those supplies. But then, at some point, they simply stopped bringing anything in. And it happened incredibly fast, within just a few minutes. Then came the chain reaction. Food is fuel, and once the colony lost its fuel supply, the whole nest stopped developing the way it should. Construction ground to a halt, activity outside the nest dropped off, and the large worker ants gradually disappeared. Imagine a colony that's been put on pause. That's more or less what it looked like. At the same time, some of the ants were behaving almost like zombies. They still moved like ants and they looked more or less alive, but there was definitely something off about them. It was as if an ant was playing the part of an ant, just so the others wouldn't realize it was a fake. Even though it was clearly not okay, an ant could still keep going for several more hours, seemingly doing its job or maybe just pretending to. And obviously losing a single ant isn't enough to bring down a massive nest, but it kept happening over and over, and each time the colony grew weaker. Fewer resources, fewer workers, weaker defenses. In other words, the nest didn't die overnight. At first, life in the colony simply got worse. Then food became harder to find. The nest became less effective at defending itself. More and more of them began behaving strangely. And eventually, all that remained near the place where a thriving colony had stood not long before were dead bodies. And for some reason, their heads were lying separately. The obvious question is, who did this? Could some kind of infection have wiped out the colony? At first glance, that sounds plausible. Ants live packed together, constantly come into contact with one another, drag all kinds of debris into the nest, and use the same tunnels over and over again. If a fungus, virus, or bacterium gets inside, a disease can spread incredibly fast. But an ordinary outbreak looks nothing like this. Infected ants usually become sluggish, lose their sense of direction, stop moving normally, and die in large numbers inside the nest or near its entrances. That's what an epidemic looks like. This was far too precise and far too strange. The workers weren't simply growing weak or losing control of their bodies, they were being decapitated. No ordinary virus does that. At least scientists haven't discovered any executioner viruses yet. Then maybe our ants had been attacked by other ants. Ants really do fight full-scale wars. Colonies battle over territory, food, and places to live. In a fight like that, heads, legs, and other body parts can easily be torn off. But that theory started falling apart pretty quickly too. An attack usually leaves clear signs of a battle. Damaged tunnels, stolen larvae, chaos around the entrances, body parts scattered everywhere. But our colonies seemed to be weakening from within, with the workers disappearing one by one. Besides, if there had actually been a fight, the injuries would have looked different. Some ants would have lost legs, some would have had their abdomens torn open, and others would have had damaged antennae. But here it was just heads. Very strange. There was one more possibility: poison. Maybe someone used chemicals and the ants had been poisoned. But poison usually kills off a colony quickly and messily. The ants lose coordination, twitch, crawl in circles, and clog the tunnels with their dead bodies. They don't slowly start losing their heads. Okay, but surely Israel, and that's exactly where this happened, has animals that can rip ants' heads off. You might think of an antlion. It even sounds plausible. Antlion larvae really do prey on ants. They're common in the dry regions of Israel, and they love sandy ground. So on paper, they seemed like a good candidate. Except antlions don't enter colonies and carry out mass slaughters. They hunt by sitting at the bottom of a funnel-shaped pit in the sand. If an ant falls in, great, dinner's served. If not, well, better luck next time. So the most an antlion could have done was catch individual workers somewhere nearby. It certainly couldn't have destroyed an entire colony from the inside, caused hundreds of ants to disappear, and above all, it would have left pits behind. Not severed heads, so maybe it was a gecko. Israel is home to Mediterranean house geckos, and they do eat small insects, but they don't tear ants apart. Geckos grab their prey and swallow it whole. If geckos had been feeding on the colony, the ants would simply have vanished. Unless it was some kind of gourmet gecko that refuses to eat the heads. Well, there was another pretty decent theory involving spiders. Black widows and other local predatory spiders are perfectly capable of catching ants, especially lone workers or scouts. But spiders trap their prey in webs, inject digestive enzymes, and suck out the liquefied insides. What they leave behind are dried out husks. Not this. And most importantly, there would have been webs. But nothing here looked like a trap in the sand, a gecko hunting at night, or a spider's work. None of the usual predator theories fit. But there was one very strange detail in the lead-up to the colony's collapse. Every now and then, a tiny fly would appear above the area where the ants lived. It looked perfectly ordinary, but the ants reacted to it as though a predator the size of a helicopter were hovering over them. The moment the fly came close, all normal activity ground to a halt. The ants stopped searching for food, abandoned their routes, and began running around in panic, hiding or freezing in place. Some even flipped onto their backs, as if trying to shield themselves. And that was genuinely unusual. Because how could a single fly stop not just one ant, but dozens or even hundreds of workers all at once? This was a huge colony full of ants, and as you may remember, they were hardly harmless little creatures. What could one tiny flying insect possibly do to them? And yet, one fly was enough to throw everything into chaos. The ants stretched out their legs, raised their heads and abdomens, opened their jaws, and tried to attack. But most importantly, they stopped doing the work they were supposed to be doing. In fact, they seemed to be absolutely terrified. The fly would dart down, barely touch one of the ants, then shoot back up and attack again. It moved so fast that the ants' jaws were completely useless against it. The colony's work came to a complete standstill until the fly finally left. But what happened next was even stranger, because not a single ant died immediately after the attack. They carried on almost as usual. And from the outside, it looked like nothing serious had happened. Sure, a fly had attacked a few ants, but they survived, got back on their feet, and went about their business. It was only after that they started acting differently. At some point, the attacked ants stopped staying close to the colony and simply left. And they didn't just wander a little way off, they left for good, forever. This behavior didn't fit anything scientists knew about ants. Normally, when an ant grows weak from illness, it dies near the nest, or even inside it. If it's killed by venom, it should quickly lose coordination and collapse almost on the spot. But this was different. It was as if someone had planted a time bomb inside those poor ants, and only once they were far away from the colony did it finally go off. The ant died, and its head fell off its body. But you know what the most interesting part is? That fly didn't just happen to show up at the colony. Humans brought it there. In fact, they deliberately released it right next to the little fire ants. The whole process looked pretty routine. First, the researchers approached an active nest with a small shovel and damaged part of it. They didn't destroy the entire nest, just disturbed it a little, but that was enough to send the ants into a frenzy. They came pouring out, scrambling around and trying to defend their colony. And that was exactly the point. Female flies are attracted to the signals fire ants give off when they become aggressive. Although, honestly, I feel like they're always aggressive, like the Hulk. Anyway, the scientists made the ants as noticeable as possible and forced them out into the open, turning them into perfect targets. Then they brought tubes containing the flies over to the disturbed nest and released them. They would usually release dozens of flies near a single nest, somewhere between 20 and 50. After that, the researchers kept poking at the nest with the shovel for a while, just to make sure the ants didn't think they could safely hide again. It was actually a huge operation. In some cases, they released the flies over active nests. In others, they took worker ants back to the lab, exposed them to the flies there, and then returned them to their colony. Sometimes they used both methods at once, and during the larger releases, they weren't talking about a few dozen flies anymore. They were releasing anywhere from 2 to 20,000 at a time. But what for? Turned out this wasn't just some random bizarre idea, it was an attempt to reunite the ants with their natural enemy. Fire ants originally came from South America, but in their new environment, there was nothing keeping them in check. Back in their native range, they lived alongside phorid flies, which constantly disrupt their activities, attacking workers, interrupting their search for food, forcing them into hiding, and generally making it much harder for the colony to grow unchecked. And since these flies naturally help control fire ant populations, researchers figure they could try using the same mechanism in places where the ants had already gotten completely out of hand. In other words, people weren't trying to wipe out every colony by hand, they wanted to build a permanent source of pressure into the ecosystem. A tiny enemy that wouldn't just poison the ants once, but would make their lives harder day after day. If I were one of those ants, I'd come up with an amazing conspiracy theory about all this. By the way, what did those flies actually do? The fly wasn't just scaring the ants or getting in the way of their work, it needed the ant itself, a living incubator for the next generation. The female would find a worker fire ant and attack. It looked like a quick, sharp strike. The fly would swoop in, make contact with the ant, and disappear almost immediately. But in that split second, it managed to do the one thing that mattered: inject an egg into the ant's body. A few days later, the egg hatched, but the larva was still inside the ant, and at first the ant seemed more or less fine. It walked around, kept working, returned to its colony as though nothing unusual had happened. But while it went about its business, the larva was slowly making its way toward the head. Once there, it spent 2 or 3 weeks growing, feeding inside the ant, and gradually taking more and more control of its body. At some point, the ant no longer behaved entirely like an ant, it behaved like something desperately trying to pass itself off as one. But the strangest part came near the end. The larva began destroying the tissue inside the ant's head, and even when there was barely any normal brain tissue left, the ant could still keep doing things for several hours. Well, at the very least, it could still move, and that was how it wandered away from the colony. For the larva, this was perfect. If everything happened far from the nest, the other ants couldn't quickly find and destroy it. After that, the ant died. The larva released chemicals that caused the head to detach from the body, and from there it continued developing inside the severed head until it eventually emerged as an adult fly. So basically, the ant's severed head wasn't just a remnant of its death, it was an actual chamber where the next fly grew. But before we go any further, I need to pause for a second and admit something. Israel really is looking into ways to fight fire ants. But the idea of releasing flies actually came from the United States. This story begins in the American South, where fire ants have been a massive problem for decades. They arrived from South America back in the 1930s, most likely in soil used as ballast on ships, and once they reached the US, they found near-perfect conditions. Plenty of food, plenty of territory, and almost no natural enemies. As a result, fire ants began spreading, attacking people, pets, and wildlife, damaging agriculture and causing billions of dollars in losses every year. You can poison them with chemicals, but that doesn't solve the problem completely because the ants keep coming back. You can't just keep poisoning them forever. Nature isn't exactly gonna thank you for that. So the United States decided to try a different approach. Bring back the ant's natural enemy, those very same phorid flies. The program began back in 1997, and it was a long, incredibly careful process. Scientists spent years identifying the right species of flies, learning how to breed them, and figuring out the best way to release them. At first, the operation was modest. A laboratory in Gainesville was producing around 1,500 flies a day. That was only enough for a handful of release sites each month. But eventually, production ramped up and the flies began to be shipped to fire ant-infested areas across the southern states, including Florida. And from there, everything happened exactly the way I described it earlier. People really did disturb the ant nests and release flies nearby. The flies would then attack the worker ants, lay their eggs inside them, and gradually put pressure on the colonies. Of course, this didn't wipe out the fire ants completely. Their numbers dropped by only about 10 to 15%. But the goal was never to eliminate every single one of them. The flies were meant to create a constant background pressure, a living control mechanism that made it harder for the ants to forage, reproduce, and calmly spread into new territory. And now let's get back to Israel. They're well aware of the invasive fire ant problem there too. The ants sting people, harm animals, and spread at an alarming rate. But as far as we know, Israel hasn't yet launched a program involving the mass release of decapitating flies. Not yet anyway. Let's say Israel decides to follow the American example. Where would it get that many flies? Catching a couple in the wild and releasing them over an ant nest clearly wouldn't be enough. Once the ants have spread across the country, you don't need a one-off experiment. You need a steady supply of living weapons. In other words, the flies would have to be bred almost like livestock. And once again, Florida offers a useful example. At first, the right species of flies were collected in South America, in Brazil and Argentina, where they naturally prey on fire ants. Later, the flies began to be mass-produced in laboratories in Gainesville, Florida. And it didn't look like an ordinary room full of jars of insects. It was a carefully designed attack system. Inside were large, well-ventilated enclosures. The temperature and humidity were kept warm and high, recreating the conditions in which the flies thrive. Then, live fire ants were placed inside those enclosures, not simply dumped in a pile, but arranged in special trays. Each tray contained 2 upside-down cups. For the ants, these were the only decent shelters available, so they carried their brood underneath them. But the system was designed so that the cups would alternately rise and fall. One would lift up, forcing the ants to rush their larvae and pupae over to the other. A few minutes later, the same thing would happen again. So the ants were always on the go. The workers ran back and forth, hauling their brood, growing, increasingly agitated and exposed, and that was exactly what the flies needed. When fire ants sense danger, they release alarm signals that attract the flies. The flies begin attacking, the ants become even more alarmed, and the cycle continues. Every morning, newly emerged adult flies would fly out of special trays right into this attack chamber. There, for several days, they would target worker ants and lay their eggs inside them. Usually, the ants were left under attack for 3 or 4 days before being removed and replaced with a fresh batch. The farm worked like an assembly line. And it still does. So if Israel ever decides to go down the same path, it won't be enough to build a simple lab. It would need an entire system. Controlled climate, enclosures, live host ants, attack chambers, and a continuous fly breeding operation, because biological control only works when you can produce your weapon in the quantities you need. Damn, I want that line on my resume. Granted, we're not talking about ant-killing flies yet. For now, it's the Mediterranean fruit fly, one of the most destructive pests for fruit crops. Israel breeds millions of sterile males and releases them over orchards and farmland every week. The idea is simple: the sterile males mate with wild females, but no offspring are produced. The next generation of pests is simply never born. It's called the sterile insect technique, and it works far better than chemical spraying. Moreover, Israel has already turned this into a full-scale operation. Sterilized fruit flies have been exported abroad, including to Italy and Croatia, and Israeli expertise has also been studied in India. There, in several mango orchards, fruit fly populations reportedly fell from near total infestation to extremely low levels. So basically, Israel already has all the infrastructure in place: insect breeding, quality control, cooling, transportation, aircraft, and aerial releases. And if the country has already learned how to scatter millions of beneficial flies to fight a fruit pest, why couldn't it someday use a similar system against fire ants? Okay, to be fair, the difference between the two is actually enormous. Fruit flies are released sterile so they can't reproduce. Phorid flies, on the other hand, need to be capable of breeding so they can establish themselves around the ants. That means a completely different kind of biology, along with different risks and testing requirements. But the basic idea makes sense. Instead of driving around with jars of flies and releasing them at one nest after another, you create a system for mass breeding and large-scale distribution. In heavily infested areas, the flies could be released over entire stretches of land at once, which would probably be much more effective. So Israel wouldn't have to reinvent the wheel. One model already exists in Florida: how to breed flies to fight fire ants. Israel already has the second model: how to release insects from the air on a massive scale. All that's left is to combine the two. But that raises an obvious question: why flies? If you're trying to fight ants, a fly doesn't exactly seem like the most obvious weapon. It's tiny, fragile, has to be bred, handled, and kept under very specific conditions. Wouldn't it make more sense to use something simpler, like an animal that just eats ants? The most obvious candidate is the giant anteater. It's practically a ready-made ant nest demolition machine, the perfect biological control agent. Release a bunch of anteaters and problem solved. Except that giant anteaters live in South America, which means you'd have to capture them, transport them halfway across the world, help them adapt to a new environment, house them, monitor their health, breeding, and behavior. Flies can be chilled, put in a container, and delivered to a lab. An anteater is a large wild animal. You can't just pack it into a box and ship it off. That instantly makes the whole operation 100 times more complicated. Alright, then maybe you could use something closer to home. Africa has aardvarks. They eat ants and termites too. The Israeli climate doesn't seem completely alien to them, and transporting them wouldn't involve quite such a long journey. There are pangolins too, another African species with a taste for ants. The problem is predators like these don't wipe out the entire colony. Sure, an anteater or an aardvark or a pangolin can tear into a nest and eat plenty of worker ants, but that isn't enough. To truly eliminate a colony, you have to reach its core, the queen and the brood. A large predator will usually just break open part of the nest, eat its fill, and leave. Whatever remains of the colony then has time to recover. And honestly, I have absolutely no complaints about anteaters, aardvarks, or pangolins. For them, it simply makes more sense not to wipe out their food source completely, but to weaken it, leave, and then come back later. They're not stupid. But as a strategy for fighting an invasive species, that's a bad approach. It won't work. Just look at the southern United States, where armadillos can tear into nests and eat insects as well. Even so, they haven't managed to stop fire ants from taking over. If hordes of armadillos in Texas could do enough damage to keep fire ants in check, the problem would have disappeared by now. But it hasn't. On top of that, introducing new animals to control the ants would be a huge risk in itself. One day you bring in aardvarks to deal with the ants, and the next you realize you've created an entirely new ecological problem, and now you need something to deal with the aardvarks. And armadillos, for example, can even transmit leprosy to humans. So strange as it may sound, flies actually seem like the safest and most logical option. There's just one tiny catch. By now, we all know how ideas like, let's bring in an animal from somewhere else often turn out. You try to solve one problem and you end up creating another. So could the flies themselves become the next problem? What happens if fire ant numbers drop dramatically, or if they disappear altogether? Would the flies switch to native ants instead? Well, here's the good news. These flies specifically target fire ants. They don't go after other ants at all. So, if fire ants disappeared, the flies wouldn't suddenly start hunting native species instead. Most likely, they'd simply disappear along with them. Still, we shouldn't expect a miracle. In other words, if Israel ever decided to use these flies against fire ants, it wouldn't be some magic erase ants from the map button. They didn't wipe them out in Florida or in the other southern US states either. The fire ants are still there. And at this point, eliminating them completely is no longer possible. The problem is the sheer scale of the infestation. In the United States, they've spread across vast areas, millions of acres. In some places, about 2 acres can contain up to 150 colonies, and each colony can have up to hundreds of thousands of workers. On top of that, several times a year, they have mating flights, with new queens taking to the air and later establishing new nests. So basically, there's no reversing this, but you can slow the takeover. The flies weaken the ants. They become less active, less aggressive, less effective at finding food, and their colonies end up with fewer workers. That gives native ants a real chance to start reclaiming their territory. In Florida, it proved effective as a control measure. Over the years, the phorid flies didn't just survive in the areas where they were released, they began spreading beyond them. Researchers tracked them using surprisingly simple traps, sticky film, pizza boxes, and petri dishes, and they found the flies far beyond the original release sites. Gradually, the flies established themselves across vast areas of the southeastern United States. By 2008, one species had spread across roughly half of the fire ant quarantine zone. Later, it covered nearly 2/3. Another species spread even more widely, reaching almost the entire infested area. In other words, the flies became a permanent headache for fire ants in the United States. And if Israel decides to take the same approach, it will most likely see a similar result. Not a total victory, but a pretty effective form of biological control. The invasive species gains an enemy that lives alongside it, follows it wherever it spreads, and keeps making its life harder, so it never gets too comfortable. Yes, it's less than we'd hoped for, but it's definitely better than nothing. You owe me a like. See you later.